So I hope you did enjoy the first video. Now we are in the second video of this series, and we are going to create our GUI part for the CanDB. But if you haven't liked or subscribed this channel yet, please make sure to do that to support my channel and my content. So let's just recap a bit. In the part 1, we built the data layer, a can frame structure, and functions to create the database and insert frame. In part 2, we built a GUI on top of it using egui. You know that I love egui, right? A scrollable, filterable table of frames and a live plot of signal value over time. So how we are going to update our project is we are going to insert a new file called app.rs. But before that, let's add some GUI dependencies that we need. So in our cargo.toml, we are going to use the eframe, and I will just explain you a bit that why, what are the dependencies and how they are related to each other. But let me just complete everything. So we are going to use egui extras here, and I'm going to copy this part from here, and the version will be 0.34, and instead of builder we are going to say all loaders, and the last part we need is the plot. So we are going to say egui plot, which will also be 0.31. Now, eframe is the application framework that we already use, is basically to create the GUI. egui extras give us basically a table builder for the data grid, and egui plot gives us a line chart. And these basically three grades are the standard combo for any GUI desktop app. So let's move to our code. The first thing we need is basically we need to go to our db.rs to create one more function called query frame, because we still didn't add it. We have initialized a database, we have inserted the frame, but there is no function where we can get the frame from, right? So what we are going to do, the first thing is to add a query a database. This function can be quite long, and this video can be quite long, so stay till the end. It's gonna be really interesting. Okay, so we are going to say query frames as frames, and we are going to take the connection, and basically we are going to take connection, and we are also going to take the ID filter, because as the can be of multiple types, we need basically ID filter. So it will be option u32, and the result will be vector of can frames. That's perfect. So I will accept the suggestion, and now we know what we are going to do. So okay, the first statement is basically we're going to do a con prepare. So how does we retrieve the data from the database? I think you already know. We say select ID and the timestamp, like all the fields you require from frames. But the thing we need to add here is, because we also we need to add the filter here. Okay, so where (1) is null or arbitration A R B I T R A T I O N underscore ID equal to this. Yes. No, I want what I wrote. Okay. So what we wrote here is that if firstly it is null, and the second thing we wrote, or the arbitration ID basically which we are sending, and the last thing, you know, we also can write. So I will just want to move where to the next statement, and then we are going to write order by timestamp, right? If you want to write descending, that also fine. So this is, we wrote our query. I hope SQL queries are clear to you, and if they are not, you can always write in the comment section, but I will move forward with our things. So what we are going to do is that we are going to create a query map. Here we are going to use the frame iterator, and I can also call it rows. And what we are going to use is we are going to use the statement.query map ID filter, which we are basically passing here, and the rows we get. So in this ID filter should represent something called OK. Before that, what I'm going to do here is one important thing which I really wanted to do is to create some variables. So let blob is vector 8 and we basically get the 4 part. Let the DLC be u8 and basically got from the third part. Let mutable data is equal to the vector of this, and then the data is basically copy from the slice, which is the blob, and we can actually ignore this. We can just write the blob. Is it 2 brackets? I think this is fine, right? So the .dlc as you said, I'm going to explain you everything in a bit, and then we basically create our can frame, which is row.get0, time is row.get1, arbitration ID is row.get2, then we have DLC is row.get3, and then we have data. In the end, what you can do is that instead of writing anything here, we can just say rows.collect, and this is basically our end statement, and now we have everything what we need. Just explaining you a bit. So what does statement.query map does? So here I went through very fast, so let me explain you a bit. Query map runs a SQL, and for now every row it gets, it runs this closure to convert that raw row into a can frame. This is what we are doing here. It doesn't run the closure immediately for all rows. It returns an iterator, and which is why we call in the last dot collect. So basically it collects everything and then it returns. I'm not going to basically go by line, but I will just explain this one because this is really new. So basically, as I explained you, this is the iterator which takes all the values of this rows, like applying all the filters and all the can frames, and then it return collectively to you. Otherwise, it will return an error. Now we go to our app.rs. This is the file which we were talking about before as well, where our GUI will be created, right? So what we are going to use here is we are going to use eframe GUI. Then eframe GUI we don't need so many things, but what we need is from eframe GUI, or actually just use eframe GUI, and then we use should I use eframe? No, I can use just eframe extras, and here I use my TableBuilder. Oh, I'm sorry, the spelling is wrong. That's why it was issued. TableBuilder, and then I also need a column. Can I just call column here, or it's wrong? Oh, column is right. And then I don't need a row for now, so I can ignore this. And then we need our egui plot. As I told you that we are going to plot things out, so egui plot, and we need the line, and instead of we need the plot, we need the line, and we need the plot points, which is really good. Okay, then we need use the rusqlite, so we say rusqlite, and we need connection. This is done. Now we are going to use some crates. We need to use the query frames, and we need to use the crate call model.call frames. Here first we are going to create a structure. So we create the structure app, in which we have the connection, which we have the frames, which we have the filter text, and the selected ID. So I will call it selected ID, and one thing which we need is basically filter text, filter underscore text, and this should be string. Okay, so here I think the above things are already clear. I will just explain you a bit of the application. What is the struct application is doing is basically the first part is a connection, so it will open the new SQLite connection from the first part, which is the initial database. The second is the vector of can frames, so the current list of frames to display on the egui part. The third is the filter text string, so what the user has typed into the filter box, example, let's say 123 for a hex can ID, so it will basically show that And then the selected ID, the filter text passed into actual number or none in the box if it is in empty or invalid. So we keep this separate from the filter text because the text can be invalid like mid typing, but we only want to requery with a valid number. Okay. Now what we are going to do is that we are going to implement two small methods for the can frame. Okay. So let's do like this. So we are going to say impl can log app. So here we are just calling it CanLogApp. So what we are going, let's call it same, otherwise you will get confused. So I'm going to call this as CanLogApp as well. But this was fine. Is something wrong here? I don't need a bracket here and there is extra. Okay. So I'm going to use the CanLogApp same name. So basically we are implementing a function for the CanLogApp. Then we come this here, and this will be the public function new, which will create a connection for self. Then the let the same will be the query frames, connection none, unwrap or default, self connection, this is this. Okay. Then we basically say function update frames, or I can actually call it refresh, which is basically take the self variable and then the self dot frames equal to query frames self dot connection, which is basically the ID filter, which is here, and that's unwrap or default. Okay. Now basically let me explain this line by line. So the first thing we are creating is called query frames. On the startup, we want to show everything. So we filter by none. Unwrap or default, basically this one means that if query fails for some reason, just start with an empty vector instead of crashing the whole app. A GUI should be usable if the query goes wrong. Then the function refresh, so whenever the filter changes, we call this to rerun the original query with the current selected ID and override the self.frames because the frames lives inside the structure. The very next redraw automatically shows the new result. So we don't need to manually update the table all or plot separately. Now we are going to implement the egui app for this. So we are going to say implementation of eframe app for the CanLogApp. Remember the update function that we created, right? Now it is our turn to use the update function, basically, which is called for every frame. So now it takes UI, it takes the GUI context, it takes the frame, which will be the frame. Then we are going to create a central panel, which will default by UI horizontal UI, then UI label something here. If the UI is okay, we are going to do few changes here because I'm going to say let response equal to UI.single-line filter by text. If response dot, so what we're going to do is that we are going to write response dot changed here, and then if the self we are going to trim it. This is really important. So few things which we need to do is that to make the UI better is basically trimmed equal to dot trim, and because as we know that it can be a hex value, so the filter text is basically trim start underscore matches 0x. Perfect. And then we are going to say the selected ID is equal to trimmed dot parse, which is going to, this is wrong. So what we are going to do here is that we are going to say selected ID is equal to u32 : from strict radius trim 16 and okay. So this is what we are going to use, and we are going to call our self.refresh that we have done. Then we don't need this here, and we are going to say here if UI dot button clear dot click, then self dot filter text clear selected ID equal to none, and then we call the self dot refresh. Then we use UI dot separator here just to create a nice thing. Then we basically use our table builder that to new UI. Then we don't need the strip. Then we say a few things here. So the first column, what we want is auto. Let it be resizable. Just rename it correctly. The second column is also the same. The third column is also the same. The fourth column is also the same. And then the header is basically what should I do with header? So let's give it like 20 for now, 20.0 comma slash mute header. Then we'll say UI, or you can also say mute header, and then we say we will do this, and we will say, and so this is quite personal, so you can actually write whatever you want. This is how we are generating the UI, so this is not something that is very familiar to me. You can do whatever you want to do here. So I'm going to copy this, and I'm going to write here UI, and then I can create brackets here saying UI dot strong timestamp, and this is done. Similarly for arbitration ID, similarly for DLC, and similarly for data. This is done. Now we are going to create our body, which is basically the kind of same, but we are going to go frame by frame. So we say frame body.row, we are going to do this, and let it be like this. Okay, so I'm not going to explain it anymore, but now we need to close everything which we opened up, and this is really important. So we are going to use tab, where we are here, we are going to use this, and this should close our update. Fine. Now I'm going to just recap everything. If you have already understood, you can just skip this section, but I'm going to recap for the new guys. So the update function, this is one function egui requires every app to implement. There is no explicit lender loop to write. egui call update itself many times per second, and whatever we draw, it becomes the next frame. Everything below lives inside this one function, right? Then we are writing the function called text in single line. This drop basically a one-line text box and critically directly edits self.filter text as a user type. That's why filter text has to be a field on the structure rather than a local variable. Then we have response.changed. Change is only true when on the frame where the text actually changes. So we used to avoid reparsing and requerying the database every time basically we redraw. Only when actually user writes something. Then this one is basically parses the type text as a hexadecimal and matches how can IDs are usually written, like 123 means 0x123, and converts a result into an option, turning a pass failure into a none instead of crashing. So basically it will not crash. Then we are at our table builder. This is basically a builder pattern. So basically each column adds one column definition, and header draws the column title one. So basically what will be your title will be like timestamp, arbitration ID, DLC, and data. And basically the body function is just creating the rows for that particular function, like for bookkeeping. Now what we want to do, the last thing from here, is to create a UI separator, or basically to the plot. So what we are going to do is that where we are, so this is our table builder, and this should be closing of the brackets, and this should be the closing of the body. So this is our table builder. What we are going to do, one more thing is called, we are going to add the plot which we wanted to do. So UI.heading timestamp plot, perfect. And then basically we calculate the plot points. So let plot points equal to the plot points, which is basically the iterator, can be a map of the frame of the timestamp where timestamp, and actually I don't want to use this here. I will use time frame, and then frame dot data of 0 at flow 64, and then we are going to collect everything. Perfect. And then let line, it will be the plot points, and then plot points is timestamp plot dot show UI plot UI dot line, and this is your everything. And now you want to close this, so you want an angular bracket here. I will just explain you a bit like what we have done here. Let me check if the brackets are closed properly. So this is the bracket and this is thing, so I think this should close perfectly. So now what we are doing here, The map function, what is called here, is basically egui plot wants each point as an xy as a pair of f64. So what we are going to use here is that we are going to use the timestamp and the first data byte as y signal. So data 0 is basically u8. We can cast it to float 64 to match the plot point expects. The second thing is to collect all the points in a xy pair into plot point that the type egui plots line know how to draw. This is the same collect pattern as a query, just built just using a different type. Now the third thing is plot new. Plot new needs a unique string ID, and egui uses internally to remember the pan and the zoom state between frames. It is not shown to the user. Shows draws basically the plot area and gives us a plot UI and add data to. So we call plot.ui.line to actually draw our line into it. Now we will go to our main.rs to update few more things. So now our currently main.rs looks like this. Now what we are going to do is that we are going to delete what we wrote here, because this is what we did to insert the something into our database, and now we are going to read our database. So you remember that our database is created here, which is obviously unreadable to us right now, but we are going to read our database here. So what we are going to do, let connection equal to initdb, but this time we say dot expect fail to initialize database, and instead of just throwing you error, let options equal to eframe, sorry, my mistake, eframe colon native options colon default. So I'm not going to use anything more. And then we are going to say eframe run native canlog viewer. We are going to use this option, and then basically we can take new, and this is basically the new syntax. Let me see if the syntax is correct. So we are going to take the cc, and then we say okay, and the box.new can say canlog new connection. Okay, I'm going to accept this guy. Now just to explain you just the last part, so this actually opens up a OS window, start egui in an event loop, and the last argument is a closure that builds our app once at startup. It hands the eframe a box called canLogApp, and from that point on, eframe calls our update every multiple times in every second. So now basically let me run, and this is a change. Also this syntax has changed between 0.27 and 0.31. So we are using 0.31, so please make sure you use the same version, otherwise you can have errors. So let me do cargo.run. It says egui plot cargo.taml is error. Yes, because I haven't written them in my double inverted commas. Let me save it, let me learn again. It's going to obviously extract everything what it wanted to extract, and then it might take some time, but before, let's talk a bit. So I hope you're able to understand and follow me. If not, you can always write in the comment section. As I told you, please make sure to like and subscribe the video to support my channel, and yes, I always thank you to be my loyal audience. So now there are a lot of errors there. First thing, use of unresolved or unlinked crate CanDB. Yes, we don't have a CanDB, so we cannot use this. So this comes from main.rs line number here, and I'm not sure why is it from here. So we want to use app. Yes, it should work like this. Let me clear it and then run it. Then the next error, this is a warning. The next error is come from UI header method not found for mutable UI. Okay. Let me see that. It's come from app.rs, and it says line number 79. 79. It says no, this is the wrong line. It does come from 79 and 20, but I'm not sure where it is coming from. So this timestamp plot is defined here, and then we are using that's strange. It should, oh, here it's coming from here. Haven't we defined UI header before? we should have defined UI header before. I'm not sure why it is complaining about UI header, but let me have a very quick look. UI does it mean UI header or it should be UI heading? Now let me use UI heading and let me check it clearly once more time. So this error is gone. Then we have use of eframe unresolved module or unlinked crate eframe extras. No, this should be correct crate. Let me see from cargo.toml. It's egui extras, not eframe extras. So this is my mistake. Let me fix that very quickly. So that should be egui underscore extras. Okay, let me clear this out. Let me run it again. Now the only error is basically the SQLite error, which is coming from the function main. And basically the function main, we go here and it says the SQLite result, expected result, comma error, and only found this. Okay, and I need to look at the SQLite definition for it. And yes, it is right, because we need to change it now, because we are not returning a SQLite error from here. We are returning a eframe error from here. So we are going to do eframe result here. Small mistakes. Now just let me cargo run it, and again it says eframe result colon is wrong, because did we import this error? Maybe we didn't. We should, or we are not returning. Maybe this is the problem. I should remove this one here. So it's somehow it's a straight line. I am not able to see my points. Okay, maybe this is the filtration ID. So do you know what we have entered here? Can I add 1? No. Or 2? No. 1, 2, 3? No. Doesn't work. So let me figure out what it will work with later on. So basically when I do here cargo.run, you can see that there is some panic which is being created and we are not able to run. So if I go to db.rs, it's because of this issue here. The thing is this, sorry, I should be rows.collect here. This is fine, but here, you know, we have to put, like, we have to cap. So we are going to cap it here, and then from slice, when we pick, we shouldn't pick it like this, we should pick it like this. Okay, so I'm going to accept the suggestion what he just said and do it like this, and this is fine. So let's see if the panic is gone or the panic is. So let's run it. We do cargo and run, and we are able to see the table, but where is our plot? We are not able to see the plot, right? And I think the plot is maybe hidden somewhere. So what I'm going to do is that I'm going to do Control X and I'm going to copy everything above that, the table, and maybe let's run it again. And if I run it, oh, now we can see the plot. Nice. And here is our table. So you can see that the whole data which we stored in our table, we can retrieve it. We can also retrieve the plot. The plot is somewhere here. And yeah, this is what we wanted to achieve. So thank you so much actually for watching my video, and then probably I will see you in the next video. Till then, have a nice day.